right, good morning, everyone. Just want to say thank you, everyone, for coming and joining us today. My name is Jonathan Gordon. I'm the Deputy Director of Clean Energy Equity at the New Jersey Board of Public Utilities, and I'll be the moderator for today's discussion on behalf of the New Jersey Interagency Council on Climate Resilience, or as we like to call it, IAC for short. We would like to thank you for joining us today to learn more about extreme heat's impacts on New Jersey's infrastructure, built infrastructure to be specific, particularly the infrastructure supporting our electricity generation and distribution systems and our transportation systems, and how to make those infrastructures more resilient in the face of rising temperatures. The IAC was established by Governor Murphy through the Executive Order 89 and consists of 26 state departments and agencies coordinating together at a state level to develop and implement short and long-term actions to address and mitigate climate impacts on New Jersey's communities, economy, infrastructure, and natural resources. Part of the IAC's mission is to educate New Jersey's residents about and prepare them for the impacts of climate change and the actions needed to protect New Jerseyans. This webinar is the fourth in a series designed to educate the public on extreme heat. The first two in the series were held last summer, the first laying the groundwork for understanding warming weather patterns in New Jersey over time and the expectations for that trend moving forward, and the second outlining the physical and behavioral health impacts of extreme heat can have on our bodies and minds. The third webinar, hosted last month, focused on New Jersey's emergency preparedness to respond to increasingly frequent and more intense heat waves. If you had missed any of those sessions, those webinar recordings are posted at the events page of Heat Hub NJ. We'll put a link in the chat there. In addition, the IAC created short summary videos of those two webinars, emphasizing the highlights of those discussions, and posted them at the Heat Hub NJ. We encourage you to review those sessions or the summary videos, as the information provided by those panels experts is foundational for the more nuanced discussions that will happen during the rest of the webinar in this series. Today, we are exploring the strain extreme heat places on New Jersey's built infrastructure and ways to keep that infrastructure more resilient moving forward. Built infrastructure generally refers to the foundational physical or tangible structures essential for the operation and growth of societies and economies. This includes transportation networks such as roads and railways, utilities such as electric power generation and distribution systems, and the communications network and other public services that support a community's ability to function, such as water, solid waste management systems. Given the broad scope of our built infrastructure, today's discussion will focus primarily on two infrastructure systems that have significant impact on the day-to-day lives of New Jersey's residents and are most vulnerable to increasing temperatures. The transportation and electric generation distribution networks this past summer provided examples of heat-related impacts on both those networks in New Jersey. Frequent train delays happen due to heat-related rail equipment issues, while thunderstorms driven by extreme heat events caused power outages and exacerbated New Jersey's efforts to keep cool. Elsewhere in the country, portions of the interstates were shut down when roads expanded, warped, and buckled from extreme temperatures. While California called for residents to voluntarily reduce their energy consumption to avoid rotating power outages during a heat wave last year, these and other direct indirect heat impacts on these aging networks will only become more pronounced as the planet warms, leading to questions about the sustainability of those existing built infrastructures and the ways to better prepare to minimize system failures. To answer those questions, we are fortunate to have a panel of three transportation and energy infrastructure experts with a wealth of knowledge on the heat impacts of the impact that heat has on those systems and the efforts underway to better protect and enhance that infrastructure. I'm going to briefly introduce each of our panelists, but please visit the events page on Heat Hub to view their full bios. First up, we have Dr. Thomas Burnett from Rutgers University. Tom has more than 30 years of research and practical expertise in asphalt materials and flexible pavement engineering. As director of the Rutgers University Center for Advanced Infrastructure and Interpretation's Asphalt Pavement Laboratory, Tom works with international, federal, state, and local officials on research, development, and implementation efforts on improving the structural and functional performance of asphalt pavements. Tom has been active in numerous federal and state organizations, including the Lead New Jersey's Asphalt, researcher of the Federal Highway Administration, Low Carbon Transportation Materials Initiative, LCTM, the FHWA's Technical Working Group on Warm Mix Asphalt, and the National Academy of Sciences, Engineering, and Medicine Transportation Research Board committees addressing asphalt technology, paving mixtures, and pavement rehabilitation, and is a board of trustees member of the New Jersey Society of Asphalt Technologists. He is an instructor for the Level 1 and 2 New Jersey Society of Asphalt Technology certification courses, and the National Highway Infrastructure course on hot mix asphalt materials, characteristics, and control. Next, we're very fortunate to have Ed Gray. Ed holds a BS and MS in civil engineering, as well as an MS in management, and has more than 35 years experience working in various positions for PSE&G. He is currently the Vice President for Assets Management and Planning, where he is responsible for electric asset strategy and reliability, electric delivery planning, utility business performance and improvement, utility finance support, basic generation and gas supply services, and energy supplier services. Ed also overseen electric service policy, solar interconnections, service and plant maintenance, and implementation of integrated mobile applications at PSE&G for both electric and gas distribution. Finally, we'd like to welcome Chris Lynn, who holds a BS in Earth Science and a Master's in Energy and Environmental Policy, and has almost 25 years experience working for the Delaware Valley Regional Planning Commission, one of the 3 metropolitan planning organizations overseeing New Jersey, and which serves Mercer County, Burlington County, Camden, and Gloucester counties in the southwestern Philadelphia adjacent portion of the state. He currently manages the Office of Climate and Environment. In this role, Chris provides leadership and coordination for the greater Philadelphia region to help build more resilient and sustainable communities. Chris's office develops plans, programs, and technical resources to assist local governments with their effort to maintain clean air and water, creating healthier and livable communities, and plan and prepare for the impacts of climate hazards and extreme weather events. Chris also serves on the Delaware River Basin Commissioners Advisory Committee on Climate Change, Sustainable Jersey's Climate Adaptation Task Force, the New Jersey Climate Alliance, and the Coastal Transformational Hubs Collaborative Stakeholder Advisory Panel. Thank you all for joining us today. Before we get started, I'll lay out a few of the housekeeping items of the webinar. The webinar is being recorded, and the recording will get posted on the events page of Heat Hub NJ a few days after the event. Audience members are in listen-only mode to cut down on background noise during the discussion. Today's format is interview style, with panelists fielding specific questions from the moderator, followed by Q&A from the audience members. If you have questions, please jot those down in the chat feature, and we'll do our best to get them during the Q&A session. So I'm really excited to be able to participate in this program today. We have a great panel, and we have some really awesome questions that we've been developing over the past couple of weeks. And to kick this off, we're going to start with Thomas Bennett. And, I really want to find out, about the potholes in my street. I'm just kidding. But on that, let's just start talking about while our transportation system was built to withstand weather, recent heat events are pushing that infrastructure to its limits, right? Is this strain mostly about the age of the infrastructure, the engineering expectations when the infrastructure was built, or some combination? Do we need to reevaluate that infrastructure given the likelihood that even more recent construction can't withstand sustained increases in temperature and other climate impacts? If you can just, take, was it the 20 some years you have, and, maybe give us a 1 or 2 minute explanation of why we have all these potholes and
Yeah,
other
I could
issues.
probably, yeah, I'll try to do that in about 30 seconds. First, good morning. Good morning to everybody. I think you have to take New Jersey as a very unique area. First off, we need both climate and, more importantly, the traffic loading to really accumulate the damage that we do see. From a climate perspective, we're unique where we could be in freezing temperatures during the wintertime, extreme heat as what this is about in the summer. Surface temperatures of our pavements can reach 140 degrees Fahrenheit on certain days. Those that try to park too far away from the beach and then walk to the water, you'll realize that the pavement temperature can get exceptionally hot. On top of that, you've got a very unique situation where we are a very heavy truck traffic state. You've got Port of New Jersey, New York. You've got Port of Philly. You got Port of South Jersey. You've got Newark Airport, LaGuardia, Philly, all bringing in goods, heavy goods that are constantly moving across the state. So our infrastructure takes a significant impact. Okay. If you look at some of the statistics, they're predicting between now and 2050 an approximate 80% increase in truck traffic weight loading. Now that's significant. So when you combine all these together, the loading stress on our pavements is significant, and probably something that was not really able to be predicted when our infrastructure was first being developed in this state. We are an extremely heavily populated state, so expansion of our transportation infrastructure system is not really going to help on that. We've got to improve what we have currently. And that's educating people. It's utilizing some of the newer technologies that are available, changing some of the design philosophies that we're currently using. We do have new and innovative materials that can withstand these large extremes in climate and also traffic. But it's educating and getting them implemented. I think that's a critical need.
No, thanks, Tom. Thomas. Tom or Thomas, what do you prefer?
Tom is perfectly fine.
All right. Thanks, Tom. Ed, would you be able to elaborate a little bit on the similar kind of aspects to that point of what is heat doing to our electric infrastructure, and what are ways that we can harden that infrastructure per se to bolster our resiliency?
Yeah, so thanks for having me. So heat definitely has an impact on the electric system. Really, the way it works, so it's really all a network, right? So one of the things we want to do, especially like in the transmission system, what we've done is post the 2003 blackout. There's a lot of changes and a lot of upgrades to systems, but more importantly, more redundancy was built into the system. So we really should not. In that case, we should not have any customers impacted by a single event, right? N-1 redundancy or N-1, depending on where you're at. So one of the ways we really need to do that is sort of have understanding of the forecast, because heat generates more load, right? And then also has impacts on the ratings of the equipment. So accurate load forecast allows us to plan and build it. We know how to do this, and we've been dealing with increasing loads since the beginning of the system, right? So the different challenges with the high heat is just that with increasing load as we see in the system, we just have to be more proactive. And the redundancy that we provide is good not only for high heat, but also just for day-to-day operations, because that's how we provide safe and reliable service to customers. So.
Thanks, Ed. That's perfect. I want to bring Chris into the conversation here. And maybe, Tom, if you want to elaborate on some of the things that you mentioned in the first question on the following, Chris' answer to this one. What are some of the direct impacts of heat on our transportation network? Are all the aspects of our transportation network vulnerable to extreme heat? If not, what aspects are the weak points that could result in road closures or rail delays or other situations? Chris?
Yeah, sure. John, do you want me to take this one first?
Yeah, I think that'd
Yeah,
be
okay.
great. And then Tom,
Okay, great.
if you want to elaborate a little more.
Yeah, sounds good. So likewise, first, thanks for the introduction, John. And yeah, it's a pleasure to be with you all here this morning to talk about this very important topic. I think I'm going to take a broad, I work in the planning field, so I'm going to take a broad planning perspective on this question. And, I sort of want to frame it. And when we think about and evaluate the impacts of climate hazards, and in this case, transportation, climate hazards, in this case, extreme heat, on transportation, we tend to look at both the impacts of the hazard on the infrastructure itself, as well as the users, or sometimes we call them the customers of the system. And we think about both of those. So for example, we look at the impact of extreme heat on infrastructure elements such as roadways, bridges, stormwater infrastructure, public transit assets, multi-use trails, etc. Then we consider separately how something like extreme heat impacts users of the system, such as transit users, drivers, roadway users, walkers, bikers, etc. So in the case of roads and bridges, there's some technical detail here, but to make it simple, extreme heat, some of the most direct impacts to the materials are, softening, rutting, heaving, buckling of, pavements and surfaces, which then lead to deterioration, critical failures, and other problems. I think it's important to note and recognize, that these impacts don't happen everywhere all the time, even, on an extremely hot day. It's not like it's 95 degrees and the roadway system shuts down, as we know. So, when we think about the vulnerability of the roadway infrastructure and bridge infrastructure itself, heat is definitely a serious impact. But for example, we think of it as a moderate impact when compared to, say, the impact of extreme heat on transit services. So in the case of transit, extreme heat can cause rail lines to buckle, bend, or kink. This is probably in some ways more likely to happen, but more importantly, the consequences of such an event are more severe. And by that, I mean a single damaged rail line can cause the entire rail route to shut down, or could even lead to derailments. High heat also routinely causes catenary wires to sag, and that's kind of a regular occurrence in high heat, resulting in lower operating speeds and route delays. It also can even strain locomotive engine operations. So when we think about the impact of extreme heat on transit, that impact is considered to be high. In terms of system users, extreme heat poses a high level of threat, and to think about it, if we all think about it, to public transit transportation, to users of the public transportation systems, and walkers and bikers. And of course, those activities often occur in tandem as part of the same trip. In this case, I think it's important to note that we're thinking about, transit users waiting outdoors at stops and stations, and especially those without shade. Another consideration is that, of course, for many transit users, transit is their only mobility option. So finally, I just want to say that all of this factors are considered systematically when we conduct what we call transportation vulnerability assessments. and address projects to minimize risks. And I'll maybe talk a bit about that more in a subsequent question. So, Tom, I don't know if you have anything to add there.
Yeah, I'll go a little bit more detail, Chris. I think Jonathan's on mute. Yeah, so and again, my area here is more on the hard side, the pavement side. And in New Jersey, we have generally three types of pavement systems. We have what we call a flexible pavement, which is asphalt, and as you alluded to, during some high extreme heat, we can get in a situation where we get what we call early rutting. Those are the longitudinal depressions that you get in the roadway, typically in areas of slow-moving, heavier traffic. Intersections are our prime example. Now, that can cause a couple of different things. One, you get this channelization of traffic that follows through. You can lose potential skid resistance in wet weather. Water has a tendency to puddle and pool in those areas. So safety can be a potential issue. One of the things that also occurs, though, in high heat on asphalt pavements is that it is a petroleum-based system, and high temperatures have a tendency to age it quicker. And so not only early life of the pavement and of asphalt pavement, you'll get a softening condition, but over the long term, it'll actually age faster and it'll be more prone to cracking. We have concrete pavements. Concrete pavements are a little bit less susceptible to heat, but due to the way that concrete is, it expands and contracts at about 2 to 4 times faster than asphalt. And you have a tendency where in extreme heat conditions, because they're created in slabs, these slabs expand, they hit one another, and then they do what they call a blow up. And so it basically right at the joint or a crack, it expands to the point where it pushes up vertically, which can create some safety issues as you're driving. And then we also have what we call composite pavements. That's asphalt over top of older concrete. And then you have a combined effect. So you've got a couple of different things and scenarios that can occur due to that extreme heat. Other things that we're also seeing because of this is in New Jersey, we've got higher precipitation rates, believe it or not, about 8% over the past 10 years. Drainage is extremely important, making sure that these pavements are designed and constructed with proper drainage. This way, water's not pooling onto the side of the road, but also it's not getting underneath the pavement. That's very, very critical. We want to keep these pavement systems dry. And last but not least, again, we don't think of it that way when we consider extreme heat, but New Jersey is seeing an increase in what we call freeze-thaw cycles, meaning that we have less complete days of frozen conditions. The pavement freezes and then thaws, and what ends up happening is that creates a weakened condition. So, Jonathan, you asked earlier what's causing your potholes. Well, I'll tell you that when you get into these situations in the spring after a winter of freeze-thaw cycles, you get a weakened support, thinner pavements, and that'll create your pothole situation. One of the reasons, anyway.
Yeah, I appreciate that in-depth look into that. And Chris, thanks for bringing up the users of public transportation. I live in Newark, and less than I think it's like less than 40% of our community owns a car. 80% of us work outside of the city. So there's a lot of people, hundreds of thousands of people throughout the state, if not millions, that are relying on public transit, either in a simple form of commuting or for every daily need. So I appreciate that. Ed, could you bring in a little more specifics to similar to the exact vulnerabilities that we have with extreme heat, and what aspects are the weak points that could result in power outages, like and different changing temperatures? So like I remember as a kid, one of the craziest things I ever saw, I think, was the lightning strike of a transformer, and with more storms being more common, with just the need of air conditioning, and even in the evening, like what different things are you seeing with our generation and transmission networks vulnerability to heat? Or
Well, yeah, so I actually, I mean, if we're going to talk about the weakest, weak point, I never like to say anything's weak, but the parts that are most vulnerable, right? So obviously, extreme weather is obviously our biggest risk, thunderstorms and tree damage and whatnot. But in terms of heat, really where we see more of an issue. I mentioned on transmission system, we have more redundancy. We plan for that, and I'll talk a little bit more about that, I think, in a further question. But it's really on a distribution system where we have less redundancy, right? It's more radial in nature, right? So single outages will result in a customer being out of power, right? So, and then you have these areas that have been around for a long time and load has grown over time. You've got, they added air conditioning, they added these things, right? So system's been around a long time. So load grows over time. And then if we have to keep up with that infrastructure to make sure we can manage that, right? So it's actually one of our programs we're calling the last mile program, where we are looking into those areas and trying to be proactively go after that. And one of the things that's actually going to help us a lot is the AMI system that we just implemented. So we will actually understand those loads at a much more localized level and can be more proactive, right, in understanding that and going after that. So I think it's really on the distribution system more because you don't have that redundancy, right? Single points of failure, customers are out. And if you get that on a wider scale, you will have, it takes longer to restore it. But that's something that we've planned for load increases over time for a very long time. I think we're getting the visibility to that now and really trying to focus on the distribution system. We've done a really lot on the transmission system for that redundancy and then bringing generation. And now we're trying to focus on that last mile activity. So I think if we're talking about the areas that are most exposed, it's really in that area and distribution.
Yeah. But just talking about generation, if you can explain to the audience a little bit about how solar panels perform in extreme heat, or even to the fact when we talk about fossil fuel powers, generators that are steam, and the fact that the state has been in a drought for more than 26 weeks, water usage is a concern. So like when we look at, different things in that sense in generation, can you elaborate a little more on that?
Sure. So basically, you're going to have two major impacts on on solar panels. You'll lose some efficiency as you go, right? They'll still operate, but they just won't generate as much as they might have otherwise. If we're talking about like a gas turbine or whatnot, two impacts of higher temperatures. One is that we're getting into the details now, but higher temperature air is less dense, so actually it brings in less air molecules. So it's less efficient, right? It actually impacts the efficiency of the unit. But more importantly, is sort of the other part of it is really the cooling part of it, right? So you have two methods of cooling this generator. One is water. So if the water temperature is ambient's higher, right, it's going to have more problems reducing it. But a lot of the newer ones, to reduce the water requirements, are using air cools. But same problem, ambient temperature is higher. It's harder to cool the unit. So you will, and then the real issue is if you have that going, then say you have a failure of a condenser or something like that, now you might have to derate the unit. So that's really it really puts pressure on the generation side of it, from the efficiency of the units and also the ability to cool them on that. As far as the transmission system goes, so as far as the transmission system goes, we actually do have ratings at 5-degree increments ambient temperature for transformers, wire, and whatnot. So we do have the system ratings change with temperature. So we have temperature-based ratings because you need to as electricity flows, you need to reduce the amount of heat. And current generates heat. Transformers generate heat as they're transforming it. So the higher ambient temperature, the less capability to reduce that heat. So it is something that we plan for, and we do have ratings that deal with all of that. So, and obviously at higher temperatures, less capability to carry load. So,
wow, that's a lot there. I'm trying to think what a good follow-up question would be to that, because we could go in the direction of talking about the technology advances that we've been seeing with energy efficiency. And then the other aspect to it is I kind of wanted to talk about affordability and how we can, grow that. Can you talk about the ways increasing demand is addressed to reduce the strain on the overall system?
Yeah. So you mentioned obviously energy efficiency. I mean, one of the things that we've kind of maxed out on, but it's been a big benefit to us, has been like things like LED lighting have been a huge benefit to the system. Actually, PSE&G system peak is still from 2006, right?
Oh, wow.
You know, we could exceed it this year, but that our peak load demand is still back from 2006. So things like energy efficiency, demand response can definitely help, but we've kind of reached a point now where, you know, a lot of the efficiency things have been done, and we probably will see load start to increase over time, right? So in the cases where that occurs, again, we are in the process of building additional stations and reallocating load, right? So we reallocate the load, which reduces the stress in these large, you know, during major heat events, but also allows for more economic activity as things move forward, right? So we can allow more, you know, whether it's EVs, other things, and even, you know, one of the things that's sort of a mutually beneficial, the more stations we build, the more solar and circuits we build, the more solar and renewables we can bring onto the system as well. So a couple different ways we try to manage this.
Awesome. Thank you so much. Chris, I wanted to expand this conversation a little bit. Other climate impacts, particularly intense flooding, also take their toll on the roads and bridges. How do chronic climate stressors affect the longevity of these parts of the transportation network? Is the combination causing new or repair road infrastructures to deteriorate faster? And also, if you want to bring up the human element of that, what I've noticed also is that people are with extreme weather, you know, um, streets that are flooding regularly, intersections that people have to then re-navigate through. Like what other aspects do these extreme weather events have impacts on our day-to-day lives, but also the overall planning of infrastructure? Like if to kind of summarize the question a little clearer, a lot of New Jersey's been the same way for a long time. Like if you look at downtown Trenton, it's literally the same exact roads from the American Revolution. King and Queen Street is King and Warren. Broad and Warren. So the question I have for you is, New Jersey's dense, it's old relatively. How hard is it to kind of change things with a changing climate?
Yeah, sure. So there was, I think, kind of a bunch of questions and a lot to, unpack there. I think in answer to, some of your first questions, the short answer is that yes, of course, all stressors compound over time. This webinar, of course, is focusing on heat, but as assets are exposed not only to more frequent and more chronic heat, but also precipitation, flooding, freeze-thaw cycles that Tom mentioned earlier, they will deteriorate faster. And impacts from one hazard, can and often will make assets more susceptible to impacts from another. And that's regardless of whether it's a new asset, an old asset, a maintained asset, a deteriorating asset, that holds true. In terms of, your latter question, yeah, it's a build out state. There's a lot of old infrastructure. A lot of our development patterns are entrenched, and they're hard to retrofit and change. We're not building out a brand new system. So it's important to take all these considerations into account when we plan and design and maintain, reconstruct existing infrastructure to take advantage of opportunities, where they arise. And it's also why we need to pay a lot of attention to maintenance. It's why assets need maintenance. And that's important for planners, it's important for asset managers, and it's important for actual inspectors out in the field to take not just current climate but changing climate conditions into account when they do their work and make decisions about future investments.
Thank you. That's perfect. And then would you mind telling a little bit of the audience about what a metropolitan planning organization is and how planning and land use zoning and even the powers of a municipality and the right of way might have to kind of build out that hardening? And Ed, if you want to talk about that too, that'd be worthwhile.
Um, yeah, sure. I think, I'll first start with, transportation planning because that's the focus here today. Local governments, especially with greater resilience, they play an important role in assessing vulnerabilities. They're most well positioned to, document, describe, and characterize, impacts that they see to the local infrastructure. And that's really important because things that are vulnerable or experiencing impacts now are the ones most likely to experience impacts or experience critical failures in the future. So we need to know about that. I think from the perspective of, from the perspective of resilience, transportation's resilience planning and investments, a lot of that work is actually better suited at the regional or state scale. For example, one of the things we do in the planning world is conduct transportation resilience plans to look at all these issues holistically. They often require complicated modeling and analysis, and therefore are typically conducted at higher scales. They ultimately serve to prioritize what kind of investments in the transportation system will be made, and a lot of that, is with federal and state funding. All that said, it's a kind of a circular process. Local jurisdictions are a key part, are integral to the MPO, Metropolitan Planning Organization processes that we run and that the other MPOs in the state run. And in the case of the counties and the cities, they're even part of, our governance structure. And I'll just quickly add that from a more, this isn't really just transportation and heat, but from a more comprehensive perspective, all hazards, all types of assets, local assets, government buildings, facilities, housing, personal property, natural resources, public health, et cetera. That kind of comprehensive resilience planning, must happen and needs to happen, at either, the municipal, local, or multi-municipal scale. So many decisions and projects and regulations and are implemented at the local level.
Ed, anything you want to contribute to that? Because I know PSE&G does a lot of work with municipalities to do pruning along power lines and other shared infrastructure collaborations. Well, anything you want to add to that? Because I think after that, I just want to jump into Thomas and talk about how how do we pay for this stuff? So, anything you want to add, Dad?
I mean, we have over 200 municipalities in our service territory, and we talk with them about lots of things, obviously resiliency, tree trimming. But ideally, as it comes to the electric system, obviously we're aware of hospitals and stuff like that, but ideally they don't worry about that. We worry about that, right? If they're supposed to hit the switch and the light's supposed to come on. When that doesn't happen, we all know about it and we take care of it. But we do have active people that work with them on a daily basis and take feedback and really we look at where we're seeing outages and whatnot and try to be more proactive and what those impacts might be in a larger storm event. So we run drills and whatnot in combination with the BPU and other municipal officials. So
awesome. So Tom, Chris had mentioned a lot of things that cost a lot of money. And I wanted to ask you, in the absence of funding to repair or replace existing infrastructure to make it more heat tolerant, what can local governments do to take stress off these systems? In addition, what can we expect road performance do to current trend in warmer conditions here in New Jersey? So is it green infrastructure? I know DEP's been working on, the stormwater utility program. There's a lot of cool opportunities, different models. Um, what do you see? What's your crystal ball tell you?
Well, I would say from a funding perspective, shaking a can at Dunkin' Donuts, candy sales, those are all very helpful. Now, just when it really comes down to it, there's going to be budgeting that obviously a municipality is going to have to work around, correct? And so it's doing what is best within that budgeting and making those dollars last. I give you an example. 2004, New Jersey Department of Transportation was rated the worst pavement network in the country by the American Society of Civil Engineers. Their way of doing things back then was a worst first, fix it mentality. Go out, take a look at what was in bad condition, and then fix it. A lot of municipalities currently are doing the same exact process. Now, the state realized we can't be doing that. We have to make sure that one, we keep the good maintained in the good. Two, we diversify, make sure that we take care of some immediate needs, but then we can't dump all of our money into a reconstruction project. And so when you look at the way that municipalities are running their network system, they have to make sure that they are maintaining the good payments in a good condition. It's called preventative maintenance. And a lot of these preventive maintenance strategies are a fraction of the cost of a typical pavement construction, 10%. And they have to really make sure that they maintain those good infrastructure in good condition at a fraction of the cost. Now, the other thing too is taking advantage of the newer technologies that are available and some of the technical expertise that's available. There's an organization in New Jersey called the New Jersey Local Assistance Program, LTAP for short. Okay, Local Technical Assistance Program. And their main function is technology transfer from the Fed state level to the municipal level. And taking advantage of those programs is extremely important to get an idea of what are the newer materials that I should be using? How can I best plan? Developing what's called a pavement management system. Okay, going out there, assessing your network, seeing what roads are in what condition, and then forecasting. A lot of it is looking into the future or trying to forecast your needs into the future so you can budget appropriately. You asked about the future and what is something that we have to consider. Well, I'll be honest with you, right now, we're already looking at these sort of things and how newer technologies are going to impact our infrastructure. This is about extreme heat. We obviously know that we have a climate condition where temperatures seem to be increasing. So that's a stressor on the system. We want to move to electric vehicles, right? Well, if you compare electric vehicles to the gas equivalent, they're about 30% heavier in weight. So that's going to add now an additional stressor. As these electric vehicles get online and we start improving our technology, we want autonomous vehicles. We don't want to drive anymore. We want to sit there, read a book, take a nap as we commute. Well, to do that, that's going to create most likely a national algorithm that's going to keep my vehicle in the lane so it doesn't depart. Now that becomes a channelized loading condition. So I have higher temperature stressors, I've got heavier vehicles, and I have more channelized loading, all need to be considered on how I'm going to design and maintain my infrastructure moving forward. Those are things that need to be thought of ahead of time as we're coming up with this planning. And so really a lot of it is taking advantage of current technologies, forecasting the future, and seeing how I can start looking at improving my infrastructure or change my planning to accommodate for that.
All right, awesome. Thank you so much, Tom. So I want to move on to some of our audience members' questions. Is there any last details anybody wants to further elaborate on, or something that we might have missed in our conversation that you feel is a really important point before we jump into these other questions? Good to go? Awesome, awesome. All right, so again, audience, thank you so much for joining us today. And for any of those that are watching this later, thank you for watching this recording. Douglas asks, how does New Jersey plan to handle the power burden over the next 5 years in terms of supplying power, gas, nuclear, 10 to 15 years, solar, to support the increase in housing development and population and technology? Anybody want to, Ed, maybe you want to touch on that a bit?
Yeah, I mean, just for everyone's understanding, like the utilities don't own generation. We own some nuclear plants, but that's the extent of it. And right now, we utilize PJM as the person to bring in generation. So they do have plans. There's queues. It's a mix of all of the above. Given the increases in load and some retirements of different generators, it's going to be an all of the above type of approach. I'd be I can't tell you exactly how it's going to go because I don't think anybody knows for sure, but we do know we have a challenge in front of us, and we've been working with PJM, all the utilities have, and to try to first get the load forecast right, and then how do we get the right generation mix, either in state or by bringing it in out of state through our transmission system.
And I'll add to that a bit myself. When we look at putting power into our system, we're talking about things that need to be studied, reviewed, planned, because you don't want to just, take a block of power, or I kind of always think of it like a plumbing system with, you have this much water running into it and getting dispersed throughout that system. Then all of a sudden you want to throw another, power generator in there, you could destroy the whole system. So it's really important to realize that a lot of studying and planning needs to be done before just putting new generation in. It's not an easy plug and play situation like an outlet. Elizabeth asked, I understand that New Jersey adopted a more stringent building code a few years ago, along with a few other states, but there will be new building codes coming out to uniformly meeting heat, wind, storm threats for the next 50 years. Another concern with the power grid is the impact of more data centers in the state, especially ensuring clean energy is powering these systems. So this is an interesting question Elizabeth has, which is, we're doing everything we can. I think, Ed, you brought up, we're trying to make things most efficient as possible, which is great. And building codes are, in my opinion at least, the foundation of where we're starting. But there's going to be these new loads coming in. Is there anything that you want to add to that? Like, what are some things that either municipalities or the state could possibly do to reduce that demand on our system?
Well, I think one thing is, and I'm not, we're here to serve the load that comes. Data centers are part of modern life, right? If you watch Netflix or anything else, the data center's giving you that thing. So, so they are. So how we're going to supply them is going to be, again, one of the challenges that we're going to deal with. That's where I came to originally. That having an accurate load forecast, which is what we're working on, what we believe, is how we can plan for it. And once we know what we need to plan for, we can plan for the right way to supply it. To Jonathan's point, it does take planning, because you need the load needs to match the generation 24/7, 365. So that's and it'll be a mix. And how that plays out is going to be something that we work our way through. So.
Awesome. So we had one more question about transportation. And Tom or Chris, I don't know if you want to answer this quick question. How can we access transportation vulnerability assessments or transportation resilience plans for our areas? What does that look like?
Yeah, sure. I'll take this one, John. So first I'll start out that a DVRPC was, working on securing funding to conduct a comprehensive transportation resilience plan for our metropolitan region. That funding did not come through, so that significant effort is on hold for now until we figure out a way to fund it. the DOT, as of late last fall, was working on a statewide transportation resilience plan and / vulnerability assessment, which are all kind of part of the same package. They were still working on, technical modeling at the time, so I'm not sure that they have, released anything public yet. But certainly getting an update on DOT's work and when they will have anything available, to be publicly released or that can be shared with local governments, would be appropriate. I'm actually curious myself to see what the latest is there. I should know. And what was I going to say? Yeah, and then there is a lot of other kind of data available to inform resilience efforts and models, but I think a lot of that work is in a comprehensive way is to be done.
Awesome. I want to try to get a few more questions in, and before we wrap up. So let me just go to my email, see what's coming so far. Okay. All right. So real quick question. How are each community, let me see. What can New Jersey municipalities, bringing up what I was talking about is the right of way, building codes. What can New Jersey municipalities do to speed up interconnection within the PJM grid, but also just general with their own communities?
So it's a good question. I should have highlighted too, like what's the utility's role in sort of getting this new generation online? We don't build it, we interconnect it, right? And in terms of what we're trying to interconnect with PJM controls that grid. So as far as, and only speak for PS, we're up to date on everything that's come in. Now, in terms of all the interconnection requests that we've got. And obviously we've done a lot interconnecting solar, whether that's community solar and other things as well. So what can municipalities do? Some of it is going to be siting, right? Unfortunately, nobody likes a lot of this infrastructure built in their town. And to the extent that, it's an essential service, that, kind of make some of that happen, or at least facilitate the conversation so we can be done in a way that's mutually advantageous, right? Not just, so I think that's the biggest thing that the municipalities have some impact on. Because everything has to be locally sited, and we do need it. And I understand not everybody might not want it, but that's really, I think, the number one thing that municipalities could do specifically. So.
Yeah, that's a great point. Before joining the Board of Public Utilities, I was at the City of Newark, and we realized with our own zoning laws, you had to get get a land use, a change of use to put solar on some buildings. So we identified that as a problem, and quickly changed that, and that opened up a huge dynamic of changing barriers.
Jonathan.
Tom, what's that? 1 second, Chris.
Okay, if I could just interrupt real quick, I'd be remiss if I didn't say that NJTPA did actually complete a transportation resilience plan for North Jersey, which was actually published last fall. So if that's the geography of any folks on the call, that is available on NJTPA's website.
Thanks, Chris. Tom's real quick. Carport solar. What does that do to asphalt? Does that reduce the stressors? Is that something that municipalities should be encouraging for these larger parking lots?
Well, I mean, and honestly, what you're doing is you're creating shade, right? And so you're relieving the
Hmm.
pavement of the solar UV radiation on it. So that's going to reduce the heat. It's going to reduce some of the aging. Depending on how the pavement is designed, you'll relieve it of some of the initial runoff or water, some of the snow. So from a protective perspective, it would benefit a parking lot. I'm actually very encouraged to see those practices being used. And whenever you can kind of double the use of something, you're creating shelter for parking. You're also creating a way of generating energy. I think it's a fantastic use.
Awesome, awesome. So I know we're about to hit time, and I just want to say thanks everyone for joining us. This is all the time we have for today's discussion. On behalf of the IAC member, state agencies, and departments, I would like to thank our panelists for sharing their knowledge with us today. We hope the audience walks away with a better understanding of how extreme heat can negatively impact our existing built infrastructure, what actions were already underway to address those impacts to protect and enhance those systems, and what still needs to happen to make sure New Jersey's built infrastructure is resilient to climate-driven extreme heat. As I mentioned before, the recording of this webinar will be posted shortly on the event page of Heat Hub NJ, along with the recording of the first 3 webinars in this series. We encourage you to visit Heat Hub NJ often, as regularly update and add new material to the site as it becomes available. And again, I really appreciate all the questions that everybody submitted in the comments. And I encourage you all to please follow the links that you see here on the screen. If you can do the little camera action there to capture that. And then also, importantly, when we talk about heat, it's been proven time and time again that extreme heat is one of the most dangerous and fatal extreme weather events that can occur. So it's not just a situation that can disrupt your afternoon and make you feel uncomfortable. It has serious repercussions across the board. And it's also been proven time and time again that communicating and building stronger relationships within your neighborhoods, your towns, your coworkers, and being able to communicate these opportunities like Heat Hub NJ to those that you may not know need it is vital. So thank you again, everyone, for participating in this panel and joining us today. And I'm very thankful for my colleagues throughout the group here to be able to share this information with our wonderful state. Thank you again, everyone. Have a great day. Goodbye.